Yay!
Yay! So far, we've done conservation of momentum in 1 dimension. Let's step it up a notch and do conservation of momentum in 2 dimensions. So this is going to be a collision between objects. Let's just, to make this one kind of easy, let's just say the 2 masses are identical. So A is going to come in and collide with B. And the initial speed of A is going to be 40 meters per second. And let's just take that to be the x direction, right? So again, the idea is that we're going to say that the momentum of the system initially equals the momentum of the system finally. And these are vectors, right? This is just 2 dimensions. So let's write down the conservation of momentum in 2 dimensions. So it looks like this. Each vector, it has both an x and a y component. So initially, if B is at rest, then the initial momentum of the system is all due to A, right? So it's just going to be 40 times m, and then in the x direction, and nothing in the y. There, that's the initial momentum of the system, because it's only A that's moving. Finally, what do I have finally? Finally, I've got m and then v. So this is going to be v a cosine 30 is the x component, and then m v a sine 30 is the y component. There we go. That's the momentum of A. And then I got to figure out the momentum of B, because this is still, I add together all the momentum vectors, and that'll be the final momentum of the system. And so I'm going to have B. It's still mass m, v, b, cosine 45, if I've measured those angles, and then this is going to be minus mvb sine 45. If I know it's going sort of down and to the right, the y component is going to be negative. Okay, so let's look at the bottom one. That's going to be pretty easy. First of all of these m's are going to cancel out, right? So this tells me that VA sine 30 is equal to VB sine 45. If I look at the y component equations, those are just 2 separate equations. So what is sine 30? This is just going to be, sine of 30 is just a half. So this tells me that VA is just 2 VB sine 45. Okay, well, I can stick that in the top equation, the equation for the x's. So this is going to tell me that 40 is going to be 2 VB sine 45 cosine 30 plus, second part, VB cosine 45. So if you plug in all those numbers, now you just plug in what all those sines and cosines are, right? So that sounds like that's going to be kind of boring. So I've already done it. VB, if you do this, turns out to be 20.7 meters per second. And then you can plug, once you have VB, then you plug that in right there, and you can get VA. And VA turned out to be, what did I get? 29.3 meters per second. Cool. So knowing those final angles and the initial speed, I can figure out, I can predict what the final speed of each of the masses is going to be after the collision. So when you do momentum, conservation of momentum in 2D, just treat them as vectors and just do the vector momentum before is the vector momentum after. You sum all those vectors together, and then you can solve for what you need. All right, so we'll do another one here in just a second.